Our goals for today, we are going to classify chemical reactions as synthesis, decomposition, single replacement, double replacement, and combustion, and we are going to balance chemical equations by applying the laws of conservation of mass. So the reaction that we're going to focus on today is actually our last type of reaction. After today we will have covered them all, and it's called a double displacement reaction. It's similar to the single displacement reaction that we talked about yesterday, but instead of having one element all by itself, so yesterday we saw A was by itself, B was with a partner, then A ended up with a partner, B ended up by itself. This time it's more like switching partners. So we start out, A is with X, B is with Y, and we end up A is with Y, B is with X. A and B would both be metals, X and Y would both be nonmetals. So metals are going to switch places and nonmetals are going to switch places. It's kind of like if you imagine square dancing. So these two are dancing and these two are dancing and then they switch partners. This guy ends up dancing with this girl ends up dancing with this guy. So compounds AX and BY are like any couple in the square. A and B are the men or the metals, X and Y are the women or the non-metals, and during the switch, the two metals will switch places, or the two non-metals will switch places, and everybody will end up with a different partner. Here are three examples of double replacement reactions. So here we have silver nitrate and sodium chloride. What happens is that your two metals here are silver and sodium, and they just switch places. So silver ends up with chlorine, sodium ends up with nitrate, and you end up with silver chloride and sodium nitrate. Here, sodium and hydrogen are going to switch places. So hydrogen ends up with cyanide, sodium ends up with sulfate. And then in this last one, hydrogen and potassium switch places. So you end up with potassium nitrate and water. And there's typically three things that can happen that will let you know that a double displacement reaction has taken place, because sometimes there will be no reaction, but these three things right here let you know for sure that a reaction has taken place. So if it produces a precipitate is just a solid, and I'll talk a little bit more about that on the next slide. Produces a gas, you guys know what a gas is, you're breathing them in right now. Or it neutralizes an acid and a base and produces water. So this is what a precipitate looks like right here. It's a new solid that is formed and can be isolated when two liquids are mixed and reacted. So you might start with two liquids, you'll pour them together, and you'll notice a solid forming on the bottom. Another thing, gases, you'll sometimes observe. This right here is an Alka-Seltzer. You can see the carbon dioxide bubbles coming out. You know a reaction is taking place because you see the gas actually escaping through the water. That's what the bubbling is. There are rules to how precipitates can form. They're called the solubility rules. Now, whenever you are writing the reactions, you'll either classify each of the products and the reactants as well as a solid, a liquid, a gas, or an aqueous solution. And if it's insoluble, it'll be a solid. If it's a gas, it'll be a gas. And if it's soluble, it'll be an AQ, aqueous solution. You might have seen that in reactions. We're not going to do too much with that, but I did want to kind of put it out there for anybody who is going to be taking a higher level chemistry. So like all of the nitrates, anything that has NO3 in it is soluble, so you'll see a little AQ after it. Same thing with the ClO4 minuses and the Cl minuses, except if it has silver, mercury, or lead with it. So if we go back to this reaction right here, this Ag with Cl is insoluble, so it would be a solid, and this would produce a precipitate. The precipitate is the solid. Try not to get too confused with that. I know it seems like a lot. Whenever we start practicing this, it'll make a lot more sense to you guys. And then some double displacement reactions are also neutralization reactions. What does that mean? So you start out with an acid and a base, and you end up with a salt and a water. So you basically, like, you guys have heard of acids and bases before. A neutral solution would not be acidic or basic. It would just be neutral. Water is typically an indication that this type of reaction has occurred. and you'll get a salt as well. And it will always be pH neutral. So here, with an acid, your pH would be less than 7. With a base, your pH would be above 7. When you mix the two together in a neutralization reaction, you end up with a pH equal to 7. So one example of a double displacement reaction that you might have seen, it's something that can soothe your stomach. So if you've ever taken an antacid before, basically an antacid tablet contains, this is called calcium carbonate, and it mixes with the acids in your stomach, HCl is an example of that, to form calcium chloride, which is neutral. So CaCO3 is basic, HCl is acidic. This is your salt right here, the calcium chloride, it's neutral. And then H2CO3, that's hydrogen bicarbonate, that's also neutral as well. And eventually, actually, this right here, this H2CO3, will break down into water and carbon dioxide. You can see the carbon dioxide as the little bubbles escaping. All right, so we have now covered the 5 types of reactions. We will be doing a lot of practice on identifying them and also balancing them. And that's what our quiz will cover. It's basically just going to be balancing and identifying types of reactions. So not a lot of material on it, but the material that's on it requires a lot of practice.